To be fully simplified, a radical cannot be left in the denominator. So if you need to eliminate a radical, how would you do that? If you think about a square root, we talked about how if there's no index, it's really a 2. The opposite of square root, if you were going to solve something, would be to square it. Those would cancel each other out. So if you think about it, if I were to square this, it means multiplying it by itself. So I would do square root of 6 times square root of 6, which would get me square root of 36. The square root of 36 is really just 6. And so if you notice, my square roots really just canceled out, and I was just left with the radicand. So anytime we want to cancel a square root, we need to multiply it by itself. So in our first example, if you notice, there's no simplifying that can be done, and so really I just need to eliminate the square root in the denominator. To do that, I would need to multiply by square root of 7. And anything we multiply on the bottom, we also have to multiply to the numerator. So then we're just going to multiply across the numerator and across the denominator. So 4 times square root of 7 is 4 square root of 7. They can't be combined because they're not both in a radical. Square root of 7 times square root of 7 is square root of 49, which is really just 7. So feel free to skip this middle step and go straight to this point. Then you would just want to check, can our fraction be simplified? And it can't. Can the radical be simplified? It can't. And so this would be our final answer. For the next example, I need to remember some of my division steps. So first thing I want to do is I want to rewrite this as 2 separate radicals. The second thing I want to do is check to see if my radicands can be simplified. I can divide both of these by 6. When I divide both by 6, I get square root of 1 for the numerator and square root of 3 for the denominator. Square root of 1 is really just 1. So feel free to skip that middle step if needed. After this, I can't simplify any further, but I can't leave this radical in the bottom. To eliminate the radical, I multiply by that radical over itself. Again, I multiply across the numerator and across the denominator. When I multiply across the numerator, I get square root of 3. When I multiply across the denominator, square root of 3 times square root of 3 is square root of 9. And the square root of 9 is really just 3. For this next example, the only thing I can simplify is 4 over 2. I can divide both of those by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. I don't really need to write this over 1, so I just get 2 square root of 3. So no rationalizing needed there. For my next example, I would want to check if I can simplify the fraction, and I cannot. Then I would want to check if I can simplify the radicands, and I can divide both of those by 3. So I have 2 square root of 3 divided by 3 is square root of 1. Over 3, square root of 6 divided by 3 is 2. The square root of 1 is really 1, so I can just eliminate that from the numerator. I can't leave a radical in the denominator, so to get rid of it, I would multiply by square root of 2 over square root of 2. Then I multiply across the numerator. 2 times square root of 2 is 2 square root of 2. They can't be combined because, again, they're not both in a radical. I'm just going to carry down my 3. Square root of 2 times square root of 2 is square root of 4. Square root of 4 is really just 2. From this point, I can see that if I have a 2 in the numerator and denominator, those would just cancel out. leaving me with square root of 2 over 3. For my last example, again, I would want to check if I can simplify my radicands, and this time I can't. So right away, I'm just going to start by rationalizing the denominator. To do that, I multiply by the denominator over itself. 4, and then I have square root of 5 times square root of 12, which is square root of 60. Square root of 12 times square root of 12 is square root of 144, which is really just 12. 4 over 12 can be simplified. I can divide both by 4, which would give me 1/3. And so right now, I have square root of 60 over 3. Square root of 60 can be simplified. I can rewrite this as square root of 4 times square root of 15. And I still have a denominator of 3. Square root of 4 is really just 2. 2/3 can't be simplified any further, and neither can square root of 15, and so this would just be my final answer.